Good morning, grade 11s. So today we are going to be continuing with chapter 3. We are looking at section 3.5, where we are working with both your standard and your factored forms in order to solve quadratic problems or word problems. So hopefully you saw the recap. Everything here is pretty similar. We're just looking at the idea that we can solve problems using a table of values, depending on how it's presented. We can graph to find our solutions, or we can look at an algebraic approach. I'm a math teacher, so I prefer the algebraic approach, but you can pick whatever method works for you. Depending on what the question asks, or even the way that the table of values works out, or the formula they give us, sometimes some methods are more suited than others, but it's at the end of the day, it is completely up to you as long as you're getting an accurate answer. So again, just from the recap, we've got all different equations that we can use for our quadratics. You had your standard, your factored, and your vertex form of a quadratic. Regardless of the form, the a value is the same in all of them. If your a value is positive, your parabola would open up like this one, where you have a minimum. If your a value is negative, that means your parabola opens down, and you would have a maximum like the second graph. Okay. We can use our zeros to solve things. Okay, our x-intercepts are zeros. So there's lots of information that we can get there. All right, so let's look at a quick example, or our first example. So in this scenario, we have a computer software company. We can see that its profit can be modeled using a quadratic equation, which is up here. This is in standard form. X is the number of games sold. P would be the profit. We need to figure out the maximum profit that the company can earn. Now, from this equation, we can't find much. If we are looking for a maximum profit, we are trying to find the vertex, right? We would be looking at a parabola that would go this way. I know that because my a value is negative, so my parabola would open down. And I'm looking for a high point, right? I'm looking for a maximum, a point up here. So I am looking for the maximum of a parabola. Now, I am going from your textbook. This is an example from your textbook. I will show you a table of values at the end, but I do want to look at this algebraically. I'll quickly show you the graph version using Desmos, so we'll use technology, and then I'll show you the table of values version that your textbook has and how you can get the answer all three ways. So let's look, there it is. Let's look at our equation. If I'm trying to find the vertex and I have standard form, I would need to find my axis of symmetry, which is the x coordinate of my vertex, and then I need to substitute that in to find the y coordinate of my vertex, which would give me my maximum or minimum. So the first thing that we have to do is put it in factored form. So I'm going to factor it. So looking at all of these numbers, the first thing you should see is that you can common factor a -2. Every time you're dealing with a factoring question, you should be looking at common factoring. So I'm going to divide every term, all these terms, by -2. So I would be left, let me just simplify this here. Oops. So I would be left with x squared, 16x, and 55. Okay, so I'm going to take -2x squared and divide by -2 to get x squared. I'm going to take 32 divided by -2 to give me -x, and I'm going to take -110 divided by -2 to give me +55. Okay. Now, this is the part I still need to factor. It's not in factored form yet. I need to have two sets of brackets. Right? So I've got to find, here, I'm going to put just negative signs for now, and we can fix this up after. I need to find two numbers that are going to multiply to 55 and add to -16. And if you think about that, think about all the factors of 55. The first ones that come into play for me are 5 and 11. And I can add 5 and 11 to get to 16. So let's go x minus 11 and x minus 5. Make sure that your signs are right. Let's see, -5 times -11 gives me +55, so that works out. And -5 times -11 does give me -16. Okay, so we found the two factors. So now I've got my quadratic in factored form. Okay, so this is factored form right here. Let's get a nice little arrow so we can see all of this. So this guy right here, this is our factored form. Okay. But this doesn't help me find my maximum yet. Oh, you'll see what I'm doing. So this is find roots. Okay. So the first thing that we're, oops, that didn't go well. The first thing we're going to do is we need to find our roots. And the next step that we have to do once we've found our factored form or our roots is we need to find our axis of symmetry, Okay, so this is the factored form. That means that my roots would be +5 and +11, okay? So my roots, x equals +5 and x equals 11, okay? So these are my two roots. We'll put those up here. In order to find the axis of symmetry, I'm going to take 5 and 11, and I'm going to find the point in between them. So my axis of symmetry, this is actually the x coordinate of your vertex. So this is going to be 5 plus 11, and then I'm going to have to divide that whole answer by 2. So I'm just going to put brackets here. Sorry, I don't have the division symbol nicely on this program. Okay, so I'm going to take 5 plus 11, I'm going to divide it by 2, and then that should give us 8, right? Because 5 plus 11 is 16. 16 divided by 2 is 8. Okay, so this is our axis of symmetry. That's the imaginary line that cuts right through our parabola. Okay, this is the x coordinate of our vertex. If I need to find the maximum or minimum, now I have to take this answer and substitute it back into my equation. I can plug it in here, or I can plug it into the factored form, okay? Just for our purposes, I'm going to use this original equation up at the top. Okay, let me just copy that. So step 3, we are going to find the max. In our case, it's a maximum, but I mean, depending on how your parabola looks, it could be a minimum. Okay. Let's go down here. There we are. Okay, so there is my equation. And now I'm going to have to take my function and I'm going to substitute 8. Okay, I'm going to take the x coordinate of my vertex, and wherever I see an x, I'm going to replace it with 8. I like putting my variables when I'm substituting into brackets, just so I don't mess up my bedmass later. Okay, so this is going to be when you do your exponents, you have to do exponents first, so 64 and then times -2. So 64 times -2 is -128. Then I need to add 32 times 8. That's 64. Well, that -110. And we're having a rough day. Well, then let me grab my calculator. So, sorry, 32 times 8. Oh, there we go, 256. So -128 plus 256 minus 110, you should get an answer of 18. Okay, so that means that your maximum is 18. So if we go back to the question, here we go. It says a computer software company models by this profit. What is the maximum profit the company can earn? Okay, it's 18. Now we're not talking $18. We are talking a profit in millions of dollars. So this would be a profit of $18 million. Okay. Okay, I promised you that I wanted to show you this question algebraically. I wanted to look at it on a graph using Desmos, and I wanted to look at the table of values. So let's look at this equation here. I've already plugged it into Desmos. Okay, so here it is. When you actually graph it, you'll notice that you do get a parabola. So we do have a maximum up here. And if you look at the vertex, okay, it happens at 8 and 18. So the vertex according to the graph is 8 and 18. And when you look at the math that we did, there's the axis of symmetry at 8, that's the x coordinate, and then the y value or the maximum would occur at 18. Okay, so this does work. So you could have plugged this in, graphed it, and looked for the vertex. Okay. The other thing that the textbook does, let's just see if we can make this a little bit larger for a second so you can see something. Your textbook gives you, there we go, a nice little graph. I know it's blurry, I'm sorry, but if you look there, you'll see the screens. You'll see the y values converge at 18. So you could just create your own table of values and then look until the numbers repeat and find the highest point there, or the single point. I don't recommend it. I find it a little bit too tedious. It's actually easier to do the algebra or to use the graph. Okay, but the textbook does show you that once. So even the textbook doesn't really think it's a great method. Okay, let's look at our next equation, or our next example. There we go. Honestly, this is kind of the same idea. We are looking at equations like this, and we're trying to, we'll say, solve them. For this example, it says Sally is standing on top of a river slope and she throws a ball. Okay, we all know what happens when you see balls and objects getting tossed. You can imagine something's here. There's Sally up at the top. Let's give her a little smiley face. There she is, smiley face. And she's tossing a ball. The ball is going to do this. The height of the ball is given by this equation where h is the height, t is time. I want to know when the ball is going to be 10 meters above the ground. So if you imagine your axes here, whoops, and here. Okay, this is your x, this is your y. I want to know when my ball is 10 meters above the ground. So 10. So if this is 10 meters high, this is what I'm looking for. So I know the y value, but I don't know x. So we can use our equations and solve for the variable that we don't know. So I'm going to plug 10 in for my y value. Now remember, this is just written as a function. This is where we want to put the 10. So copy my equation down so you can see what's going on. Okay, you can imagine this like having a y, but I want my y value to be 10, so I'm going to substitute that in, and now I'm going to solve for t. Okay, so I'm going to bring the 10 onto the right-hand side. It's positive here. When you bring it onto the other side, you're going to make it negative, or you're going to change it into a subtraction sign, because it is, in order to remove this 10, I would have to subtract 10 here. So my next line, I'm going to have 0 equals -5 t squared. Basically going to have this all written out again, but with the -10 at the end. (250 minus 10 is 240. And now you're at a spot where your job is to solve for t. The easiest way to do that would be to find to factor it and find your solution, right? Which would be to find your value for t. So we can actually solve this by factoring. I'm going to factor one more time. We're going to find a common factor. So 0 equals -5. Oh, I guess I'll do this the long way first. Inside my brackets, there we go. So if I factor out a -5 from here, I should be left with t squared. If I factor out a -5 from -10t, I should end up with +2t. And if I factor out a -5 from -240, I should end up with -48. Now I need to factor inside my brackets. Okay, so I've common factored the -5. And now I'm going to factor t squared plus 2t minus 48. So you have to find two numbers that multiply to -48 that add up to 2. +8 and -6. So t minus 6 and t plus 8. Okay, so just double check. -6 times +8, you get 48. -6 plus 8, you get +2. Okay, so that would be my factors. I factored it. I've got it in factored form. These would be my x-intercepts. Okay, so t equals 6 and t equals -8. So remember, when you're pulling them out of the brackets, these are the factors right here in the brackets. And when you pull them out, these are the solutions. Your signs are going to change. So a -6 in the brackets would be a x-intercept of +6. And a +8 inside the bracket would be an x-intercept or a root of -8. So that means that your ball would hit the ground at 6 seconds and -8 seconds. -8 seconds doesn't make sense for our scenario or our solution, so we're only going to accept 6 seconds. So therefore, the ball hits the ground, or the ball is 10 meters above the ground at 6 seconds. There we go. Okay. All right, so you've got 2 examples. If you don't like my explanations, I'm trying to keep the examples consistent with the textbook, so you guys can look at the textbook. And again, if you don't like my videos, please go find something online. All of the examples are going to be a little bit different, or all of the questions. Do your best. Solutions are online. You can always wait for our help hours or our office hours to ask for questions, to clarify a few things, or you can send an email. I can do my best on the email. We'll see how it goes, okay? Good luck, guys, and stay safe.